If you've ever had to do a lab experiment, a science fair project, or a research study, you've probably had to write an academic paper to accompany it. Today we're going to be looking at how you can use the engineering design cycle in order to improve your research reports. Hi, I'm Erica and welcome to Creative Engineering. If you haven't had the chance to watch our video where we show you how to use the entire design cycle, make sure you check out this link and watch that video first, and then come back when you're ready to see how you can implement it into your academic life. As a third-year electrical engineering student, I can assure you that writing a research report is a skill that you will need to practice to get good at. In all fields of STEM, students begin writing research papers as early as the beginning of high school and will continue to write them all the way through their undergraduate degrees. Each different subject and field of study will have specific requirements for what you need to include in a research report, but today we're just going to look at a basic outline so that you guys can adapt it to meet your specific needs for whatever course you're writing for. Anytime you're using a scientific method to test out a new idea or innovation, that is a research study. And anytime you're doing that for an academic course, you will probably need to be writing a research report with that. We're going to be going through all the different steps of a research report and showing you where you can implement the different steps of the design cycle in order to improve those certain sections and also make the overall execution of the paper more clean and organized. So whether this academic paper is for something like a science fair project that's self-led and it's a self-study that you get to control completely, or whether it's a science experiment that you do in a laboratory that has very specific procedural steps that you need to do with a class. This can work for both kinds of studies. You just need to adjust it a little bit depending on what your specific requirements are for that course. We're going to be looking at all the different sections of a research report and how you can implement the design cycle in those different specific sections in order to improve your writing. To begin, we have on the left here the engineering design cycle reminder. This reminder also has the color-coded icons that go with each step of the engineering design cycle. That way, throughout the report tutorial, we can make notes of what steps of the engineering design cycle we are using during what part of the research report. And just a reminder that down below we have a link to a downloadable and printable PDF of this research report outline with all the steps included in it. That way you guys can reference it whenever you are writing your own research report. So to begin, if you are doing this report as a self-guided study or a science fair, you want to make sure that you are defining your problem. You want to know what you're trying to accomplish from this report, what kind of data you want to include, and what kind of question you are hoping to answer with this report. Another thing that you want to do if you are doing this as a self-study is to do lots and lots of research before you ever start to experiment. So you want to make sure that you have all the background theories, any kind of formula you need, whatever kind of setup you can do in advance before you start experimenting. Speaking of setup, we also want to do lots of brainstorming for how we want this experiment to play out, and we also want to make sure that we know exactly what materials we're going to need and what process we're going to go through during this experiment to get the results that we're hoping for. If you're doing this lab report as part of a course or curriculum, you also want to be doing the define step before you begin. That way you can ensure that you're understanding what the point of the lab is. Oftentimes when a teacher gives you a lab, it's to demonstrate what is happening in your course material. So you want to make sure that you are defining what the objective of the lab is before you ever enter it. The other thing is that if this is a lab report that is for a class, you want to make sure that you're doing any kind of research required before you go into the lab. That means if there is terms you don't understand in the lab manual, if there's equipment you've never seen before, you want to make sure that you're doing that kind of research before you enter the lab. So once again, this is the difference between doing a self-guided lab and a lab report. The first part of a lab report that you will need to write is the title page. This title page is going to be the front page, the cover page. Depending on what year of study this is, your teacher or professor might not require you to have a title page, but typically they would. A couple more things to include are the name of yourself and your lab partners, if you have any lab partners, the date, who you're writing this for, and who your audience is, so make sure you're keeping that in mind. A specific thing that you could do here as part of the engineering design cycle to help improve it is doing a little bit of extra research. So Googling what a correct title page looks like, looking into different styles of title pages, different requirements of title pages, what they have on them, where the information is placed. A lot of times your teacher or professor will specify this right from the beginning, but if they don't, then it's good to do your own research and make sure that you're creating a clean, professional title page that's to the best of your abilities. The next thing that we're going to look at is the abstract. Once again, this is one of those things that is a little bit dependent on what level of course you are in. So if this is a level of course that requires an abstract, make sure that you are looking into what those requirements are for the abstract. An abstract is typically a summary of exactly what happened, what the purpose of it is, the key findings, the significance, and you want to make sure that you're including all of your major conclusions in your abstract. You don't want to be withholding that information until the end. The point of an abstract is to make sure that if someone doesn't have time to read your entire report, that they will still be able to read your abstract and see exactly what happened and what they're supposed to learn from your report. Personally, I like to do my abstract last. I find it most helpful if I can write my entire report, see it all as one coherent piece, and then summarize it in one paragraph for my abstract. To apply the engineering design cycle to the abstract, if you've never written an abstract before, make sure you're doing some additional research to see how the tone of an abstract is, because typically it's very different than the traditional writing styles that you're used to. It needs to be very, very concise. It's almost like there's a formula to an abstract, so it's really important that you're doing a little bit of research to ensure that you know exactly what kind of expectations are required for your level of lab report. The next thing you can apply from the engineering design cycle to the abstract is the state of iteration and improvement. So even though I said to do this last, it can be really helpful to write this abstract a couple of times, get someone to read over it, maybe even get your professor or teaching assistant to look over it. That way you can ensure that your abstract is an accurate representation of everything that's happening in the lab and is communicating it effectively. Moving on, the next thing you want to include is an introduction. The introduction is where you'll be writing the majority of the background information, any theories you need to explain, any kind of previous research or relevant formulas. You also want to be explaining what the point of this research is and why the reader should be looking at this lab report to begin with. If your introduction material is really lengthy, it's really recommended that you're using subheadings to break that up. So if it's more than a page or more than half a page, then your sections being broken up by subheadings can help make your paper really, really concise. The steps of the engineering design cycle that you can use to improve your introduction is the define step. So you want to make sure that your introduction is clearly defining exactly what is happening. Another thing to include is the research step. The research step can be really important here to make sure that you are clearly and accurately describing all the background information, and also that any previous research that you include is properly cited and properly explained. That way it is credible and real. That way you can use the research that has been done previously in order to back up and support any kind of scientific claims that you are making as a result of this lab. And another step of the engineering design cycle that you can apply to your introduction is the iteration step. The iteration step is so important with your introduction because as you are going through your lab report and writing it, you might realize that you need to talk about a concept that you haven't already explained in your background information. So if this is the case, you want to make sure that you're going back to your introduction, adding in any relevant terms or jargon that you might have, anything that you might be needing to discuss or reference later in your report. You want to make sure that is all included in your introduction. Moving on, we have the methods and materials section. This is also known as equipment or apparatus sometimes. This can typically be included as a simple list that is just exactly stating what materials you used in your experiment. But if this is a more advanced kind of lab report, or it is one that you are conducting on your own, it might be really helpful or even expected of you that you are including a schematic diagram. The schematic diagram needs to be very, very specific and to scale, and it needs to be an accurate representation of your entire scientific setup. Sometimes your professor might state that you are allowed to reference your lab manual as your methods and materials section if it's the exact same and it's a standardized setup. If this is the case though, you really want to make sure that you are noting any changes that you have to your experiment. That way your instructor or whoever's reading it knows exactly what materials were used to perform this lab. If this is a self-study or you are doing this lab on your own, then it can be really, really beneficial to implement the brainstorming section of the engineering design cycle. Implementing this section into the methods and materials section of this report can have fantastic results in making sure that you are using the most efficient and most effective setup possible. This also will be important to keep in mind if, as you are doing your experiment, something goes wrong or you realize that you could have used a better material. It's really important to keep that brainstorming mindset active anytime you're doing a self-guided study. That way you can change and iterate as you go in order to improve your methodology. Another thing to include from the engineering design cycle in this case is research. So if there's any point where you don't understand how to use a certain material, or if you don't understand why you are using a certain equipment to test something or measure something, or if you don't really know how a certain software works, It all can depend, but you need to make sure that you're doing that research before you enter a lab. If you're in the lab and realize you don't understand how something works, and it's super important that you're asking questions to your lab technician or your teacher to make sure that you are getting the most out of your lab and learning exactly how things work and why they are working that way. The next thing that we want to include is the experimental procedure. This is where you'll be describing the process in chronological order of everything you did to complete this experiment. If you are completing your own study, then this is typically the space where you will have the most freedom of brainstorm and design. You have full creative freedom of how you are going to do this procedure, how you want to test things, what you are actually trying to look for, what equipment you can use, and so this is one of the great advantages of doing a self-guided study. If you are doing this as a lab report, then you will be doing it as a procedure that is provided for you. But either way, it's really important to understand exactly how the procedure works. This is a very important part of the lab report because that way if someone is reading it and they have never done this lab before, they should be able to read just your procedure and then copy the exact steps that you took to get the results that you did. In addition to this, the step of iteration is super important here because if you do a procedure and something fails, you need to be able to reiterate that as many times as needed in order to get it to work. This is a huge step with anytime you're designing anything at all, is the iteration process of improving and getting things right. This could be in the sense of material selection, it could be in the sense of just getting the hang of the equipment that you're using, or it could be in the sense of needing to recreate your procedure if something isn't working how it is supposed to be. In both cases of a self-study and a provided lab manual, it can be really important to do research in the procedural aspect. If you're doing a step in a lab that you don't understand why you're doing it or how it actually affects the step of the lab, it's super important that you're asking questions or doing your own independent research to make sure that you understand what's happening and why it's happening. Or if you're doing it in a larger scale or as a self-study and you don't understand why you're getting the results that you are, it could be something to do with your procedure, and it could be as easy as asking someone if they can look over your procedure, making sure that you're doing all the steps correctly, making sure that you have the right process to begin with. So research is, as you can see, a super big part of writing any kind of lab report, but is especially relevant in the procedural part. That way, if anyone was going to recreate your experiment for any reason, they could follow the exact steps in your procedure and hopefully get the exact same or very similar results. Speaking of results, that is the next section of our lab report. Here is where we will include any calculations, any tables, any figures or graphs. Often if you are doing an experiment that is very calculation dense, you will be able to include simply the sample calculations in your report, and then you would add the full calculations into your appendix to refer to if your reader was looking for additional information or data. In this case though, you want to double check with your teacher, professor, or lab assistant that you are doing what is expected for that lab report. So if they want all your calculations included in the body of your report, you need to make sure that you're doing that specific to whatever kind of course you are looking for. Also, if you are including it in the appendix, just make sure that you are referring to your appendix as needed and anytime you are referencing it. The other thing you want to make sure about in your results is that you are stating your results in words. So you can't have any heading stacking, so you couldn't say results and then the very next thing is a subheading that says calculations. You need to have at least one or two different sentences in there that introduce what you're talking about, that set the scene for what your calculations actually are, and you want to make sure that you're giving context to the numbers or the graphs. You really can't just plop in a bunch of numbers and expect your reader to interpret them in the correct way or actually get any value out of them. So you want to be explaining in paragraph form what you are doing in the calculations and why you are doing it. You can use the iteration step of the engineering design cycle to improve your results section by redoing your calculations as many times as needed, making sure that you are double checking your graphs, double checking everything to make sure that you are correctly interpreting the data, to make sure that you are communicating it in a professional and scientific manner. That way your results and your data that you've collected in this experiment are actually going to be valid. The other aspect of the engineering design cycle that we are going to use in the results stage is the test and analyze section. Obviously, we are going to be analyzing this data at some point, so you want to make sure that when you're testing it, you are collecting ample amount of data that can actually support your claims and support your thesis of this paper. Test and analyze will likely go hand in hand with your iterate and improve, because if you are testing and if you are analyzing and you're not getting correct data, or there's something wrong, or you can't find the data that you're looking for, then you'll be iterating this in order to improve it, in order to collect accurate results, in order to make sure that you are able to analyze this data properly in future sections of this paper. That way you can communicate what happened in your experiment effectively. Speaking of communicating, the next section of our lab report is the discussion section. This is arguably the most important part of any lab report, because it is where you are able to communicate your understanding of what happened. So all of that data, all of those calculations you did are really great, but if someone isn't able to interpret them, then there's no point in really even having them, because they don't mean anything without context. So the discussion section of your lab report is where you'll be giving that context. You want to ensure that you are explaining, analyzing, and interpreting your data to the best of your abilities in order to answer the question, what is the meaning of the results? In the discussion section, there could be a lot of different things incorporated. It all depends on what kind of a course you are completing this for, or if you're doing it as your own self-study or a science fair. If that's the case, then you want to make sure that you are including anything that is relevant that will help support your claims in the discussion section. Sometimes your professor or teacher might ask you to include specific things in your discussion section, such as the experimental or human error, anything that affected your results that made it different than the expected results. And they might even provide some questions that they want you to answer specifically in the discussion. That way they can ensure that you are correctly interpreting the information and learning from it how to apply the specific concepts that they are teaching you during your course. When you analyze the strengths and limitations of your experimental design and of your process, this is typically where you will be identifying if there is any iteration needed. So if it's your own independent study and you see that things didn't really turn out the way that you want to, this is where you would discuss what happened, how you could improve it, what you want to change, any kind of future research, and you will also be discussing how you would change your experimental design if you were to complete this again. In the discussion section, you will also be using the test and analyze aspect of the engineering design cycle. Anytime you are comparing your results to those that were expected, anytime you're discussing what happened in your data, or trends that happened, anytime you are referring your data, some of the questions that were provided by your professor, anytime that you are looking at what actually happened and analyzing that through a critical mindset, you will be using the test and analyze section of the engineering design cycle already. So understanding that and applying that deeper will help to improve your writing, because it will help to lead and organize your discussion in a way that makes sense and that you are communicating your results in an effective manner. The next thing that you will include in your lab report is a conclusion. This conclusion doesn't have to be very long. It can be 1 to 2 paragraphs, depending on the size of your research and all the data that you collected. Really, it's just used to summarize and wrap up the end of your research report. What you want to make sure, though, is that you're including what you know for sure as a result of your research and your experiment. You can include additional things, but without this statement, your conclusion is not finished. So make sure that you're including that, and you're including it in a specific and concise way. Like I said too, right after the research report is when I like to go back and write my abstract. That way I can make sure that my abstract is super relevant and super conclusive. As far as the conclusion goes though, if you're including any of these 3 points, you might be required to do a little bit of additional research. That way you can speak effectively and scientifically about what you are suggesting or what you are identifying as a weakness. Make sure that you are supporting your claims with background research or evidence. So if it's not evidence that's coming directly from your report, you want to make sure that you're using that as a super clear and properly cited source. During the conclusion, you might also be incorporating the brainstorm section if you are doing this as a self-study or as a science fair, or even if you're just doing it as a lab report. You want to be constantly thinking about, how can this be improved? Where else can I apply this? Does this make me think of anything else? Can I draw any connections? And that's really how you're going to be deepening your understanding. And once you deepen your understanding, that's going to allow you to deepen your discussion and make your lab reports that much more credible and also interesting. And who knows, maybe when you're writing your conclusion, then you're considering what some of the future work is. That gives you an idea for your next experiment, or that gives you an idea of something that you could look into further, or it gives you an idea of something that you could design. So especially if you are doing this as a lab report that is in class. Thinking in the conclusion section, how can I apply this elsewhere, could be a really good way to widen your horizons and widen your depth of knowledge, because it could lead you to doing further research on a different topic or on that specific topic. That brainstorming could very well lead you to designing a new experiment. It could lead you to designing a new product, or it could lead you to even just thinking of a new way of doing that same experiment, which is always okay to discuss. Who knows, that when your teacher is reading your conclusion, they might even realize that there is a way that this experiment could be improved effectively, and then they could do those changes if they have control over the curriculum that they're teaching. Lastly, once you write your conclusion, go back and write your abstract, then come back to your conclusion after reading through your report one more time, and make sure that your conclusion wraps up any of the loose ends that you have talked about in your report, and it addresses everything that you have discussed and summarizes that all in 1 to 2 concise paragraphs. At the end of every research report, you need to be including your references. So these will be listed according to whatever specific style you are writing in, whether that is APA, IEEE. I know there's a couple other ones that you can write with as well, so just double check with your teacher or professor what writing style you are supposed to be using, and then ensure that your references match that perfectly. You also want to make sure that your citations match the references. So everything you have referenced in your references page needs to be a citation that occurs somewhere in your paper. That way, if someone is reading your paper and they see an in-text citation, they can go to your references and find the full information about that source. Your references page also should be its own separate page. It shouldn't be at the bottom of a conclusion. It shouldn't be starting anywhere other than its own page, references title at the top. Applying the iteration step here is going to be super important to make sure that you have fine-combed all of the details of your references. So you can't have any spelling mistakes or errors or capitalization mistakes or punctual errors in your references in an academic paper. So it's super important that you are going over this multiple times, possibly getting someone else to look over it, and making sure that your references are all properly formatted. If you're unsure of how to properly reference your citations, then you need to be doing a little bit of extra research in order to make sure that they are properly fitting your specified style. There are tons of resources out there explaining exactly how you should be referencing things, when you should be referencing things, and what the specific mechanics of each reference are. So make sure that you are utilizing those information sources and giving proper credit to people who deserve it for their work. Doing research in this example could also mean asking questions from your teachers or any kind of librarian, or writing resources that you have at your school. That way you can make sure that your references don't have any small mistakes in them. If you get to the end of your report and you realize that you don't have any references, then you really need to be doing more research. Basically, you can't be making claims if you don't have any evidence to support it. Another thing that you could do in your references section is incorporate the share method of the engineering design cycle. So if you have someone else in your class or lab partner, you might want to go even to an upper year student and get them to look over your references. Make sure that you have enough references. See if they have any additional references or resources that you could be using, not only to include in your references page, but also to help you find more information that you could then use to support your further claims throughout this research report. So you could go back using that iteration step, touch up anything, add in some extra details, add in some other evidence or theories to make sure that you actually have enough data, not only from your raw experimental data, but also enough resources to back up what you're saying. Lastly, in this report, we have the appendices, and you might not have any appendices in your lab if you are doing a smaller lab with less data, or if your data can be included directly into your lab report because of its size. But if you do have your appendices, they would come after your references, and you can include anything from your calculations to any large graphs, figures, or tables that you have from your data. Each category of appendices should have its own separate appendix though, so your calculations would have its own appendix, graphs would have its own appendix, and also the figures and tables would all have separate appendices. And so you want to be making sure that you are labeling these appendices in a way that makes sense, in a way that is organized, and in a way that you are able to reference them easily. So if your appendix A, for example, was your calculations, then you would reference it in your paper as A1 calculating whatever kind of formula you're doing in that instance. It's super important for you to know that you need to be referencing each appendix at least once in your report. So you can't have an appendix full of graphs and not talk about the graphs anywhere in your report. So someone shouldn't be surprised by anything in your appendix, because you should be referencing it at least once throughout your report
That way they know to go to the appendix to find more information about whatever you're saying. If you've never written an appendix before, then it is super important that you're doing your research to figure out how you can structure it, how it is supposed to look, when you should be using an appendix or not. You can also ask your professor or your teacher if you are required to have an appendix or if it makes sense for you to include one in your report. The other thing is that the iteration step of your appendix is super important, because as you are writing your report and you are realizing that you are needing to include additional data or information, that is when you'll be adding things to your appendix as you write. It shouldn't just be something that you slap everything into when you're done your report to make it look bigger, and it also shouldn't be something that you are just throwing things in as you write and never checking on again. So you want to be double checking your appendix, making sure that it makes sense, making sure that if it is very lengthy that you are including a table of contents, and if that is a table of contents that you are including at the beginning of your report, then you want to make sure that you have a table of contents with all your headings and subheadings, and also the list of tables and the table of figures, and making sure that those are properly listed in the order that they appear within your report, and making sure that those have the appropriate page numbers associated with them. Like I mentioned earlier, we have a printable and downloadable PDF for everyone in the description that you can use as a tool to help you write better lab reports moving forward, to remind you what steps of the design cycle you can apply throughout your report in order to improve it.
I hope you found this video useful in how you can use the engineering design cycle to improve your academic writing with research reports. If you're interested in learning more about students like you who are making a difference in STEM, then make sure you check out our Youth in STEM podcast. It airs every Monday on Spotify and Apple Music, and we have the links below in the description. Thank you for watching this video, and if you got any value out of it, please consider liking and subscribing, and hit the bell icon so that you never miss a video. We post new videos every week to help empower students to improve their design thinking skills and take a creative approach at real-world engineering problems.